Hello, everybody.
Hi.
Okay, let me just see if anybody else wants to hop on. Okay, so I'm going to start off by sharing Gephi. So I'll just open up my Gephi. Okay, perfect. And I'll record this, so I'll put it up on YouTube as soon as it encodes. So I'm going to use so everybody, you should see my Gephi right here. Okay, so this is I just opened up Gephi on Mac OS. It's opened up. What I'm going to do is actually open up the Stonewall file. So I go to File, which you may not be able to see the menu bar. I go to Open, and then there's actually that Gephi file that's from the awk derivative. So that's 12143. That's the Stonewall thing, Gephi.gexf. And so I press Open. And then this pops up, and this can be useful just to make sure that you see this because it's working. And then B, you actually get an overview of just how big it's going to be. So Stonewall is actually a fairly big collection. There's about 30,000 domains in that web graph and 62,000 links. So the first thing with the big one is we'll have to filter it down, but I'll press OK, and we'll see it.
We can't see that. Whatever just popped up, we couldn't see.
Okay, so when I went to File, Open, I clicked on the file, the Stonewall Gephi file, the GEXF file, and opened it. And then a little window popped up just saying, here's some basic overviews, and I just pressed OK.
Got it. Okay, thank you.
Okay, so there I get Gephi, and you'll notice once you load this in, once in a while this graph is missing. And if something's missing, you can actually just go to the window menu, which again, you can't see because of Zoom. Actually, I guess, why don't I show you my entire desktop? Okay, you should now see my whole desktop. So, here is, you're seeing everything, right? Okay. So yeah, so up here, window, sometimes this graph disappears and then you can just press graph and these are different things to appear. So if you don't see this, once in a while, this main graph is empty, like you sort of see this. If you go window graph, it will pop right back up. Now with a graph like this, the first step is often you look at that and you say, that's like overwhelmingly big, especially when we only have a few hours to work with this. So on the right-hand bar here is, you can see different things you could run, which are filters and statistics. The first thing I'm going to do here just to make it manageable is filter it down. So I'm going to use just in degree range. That means how often a domain is linked to. So let's say we're only interested in the places that are receiving a lot of inbound links. Let's get rid of the random stuff. Yes, yeah, Cal, this is an output from the Auth Cloud. This is the GEXF file from that download. So then I drag in degree range here to queries. Again, we've got some tutorials, and I'll put this up on YouTube because you may forget. Double click on the 0, I press 10. And so we're saying in this web graph, anything that doesn't receive 10 links, let's get rid of. And then it actually starts to become something a bit more manageable to work with. And maybe when I say that's overkill, let's say 5. And a few more appear, but in general, that's gonna help us there. Okay, now right now you got a cool little graph here, not terribly useful necessarily because we don't know what anything is. So let's first of all turn on labels. So to do that, you'll see down here there's a T, show node labels. We click on it, and then we can actually see that labels are beginning to appear. Problem is, you can't read the labels. They're too little. We could zoom in. I'm using my mouse wheel to go in. I'm using my mouse wheel to go out, but it's still not the most useful visualization in the world. So we can actually change we can load up appearance. So if this isn't here, you go to window menu, press appearance, and it will pop up. And we can say, let's make labels bigger the more often they're linked to. Let's say the labels that are more important, let's make them bigger. And so I can click on this TT thing, label size. I click ranking. I click in degree, and I say the smallest one should be 0.1, the biggest one should be 10. We'll try it out. I might try out degree. The most links are coming out of Wikipedia. The most links are coming in from, the most links are going in towards Twitter, Facebook, Pinterest, WordPress, that sort of thing. So let's do that. Let's rank them by in degree. This one here with the little circles is the relative size of things. And we could just sort of monkey with the minimum and the maximum size. Now this looks kind of weird, so let's change the layout. Again, I know I'm going relatively quickly. I'll send you the reference guide afterwards, and hopefully between seeing the tutorial and the reference guide, you'll be able to. And then we can pick a different layout. So I'll pick a layout here, if and who proportional. These are all arbitrary in different ways. That one doesn't seem to want to work. So basically, there's no magical way that we lay out network graphs. It's all arbitrary, the actual placement of the nodes and the edges. So here it's starting to move. It's a little bit slow. I think I'm encoding a video in the background here, which is kind of annoying. We can run label adjust, so we can slowly begin to see labels changing. I'll shrink the labels down a bit. Yeah, and so we might say, hey, this is useful. We might want to actually run some sort of different detection things on here. So I'm going to run PageRank, which is Google's way of seeing what are the most central sites. I run that. I'll run something called modularity, which is a rough community detection algorithm. So we can find different websites that tend to have consistent parts of the network where they're linking to each other. Let me just use PageRank now. So here nodes are big. The bigger they are based on the higher the PageRank, the bigger the label based on the PageRank. And then I'll click on the pages palette. I say partition. Again, this is all in that tutorial. We can color them so we can actually see what community detection we've got here. Social media seems to be given a blue community. We have this green community down here, which is all images. So people are linking out to sort of image servers. We see media. We see, Google Maps, etc. We see some of these major media things. So I guess this is all the news outlets that were reporting on the Stonewall 50 commemoration. Kinja.com, I don't know what that is. AARP.org, that's interesting. The American Association of Retired Peoples is popping up prominently in this network. Tumblr, obviously, which we'd expect to see. Columbia.edu, which is a little bit surprising. So we can just sort of begin to see, what we're looking at. I might be just beginning to ask questions. I don't know anything about this collection, but it's interesting to see AV Club was part of the collection, Columbia University part of the collection, iTunes part of the collection, Eventbrite invites, etc.
A Columbia professor built this collection, so I think that might be maybe explaining that. That's interesting, though.
Yeah, that they were sort of interested in some other institutional stuff, or?
Yeah, and his own website and his own stuff. Yeah.
Oh, okay. Yeah, so or NYPL. So you just sort of, as you get a sense of what's going on. What are the sort of main hubs in this web graph?
Ian, can I chime in?
Yeah, please do.
What does the link mean? I know you have the direct data, but does that mean people search from Google, then they jump into Columbia EDU, then find that collection, or?
Yeah, so let's take one. So let's take AARP, for example. So AARP, we can see that it was part of the collection. I don't have everything. It was part of the collection, and we can see who linked to it. I can make an ego network, but we can see that AARP linked out to, sorry, Zoom must put a load on your computer because this is going, probably because I'm recording. We can see the AARP linked to YouTube. So it's somewhere on that, when the page AARP was harvested, the American Association of Retired People was harvested, the web crawler captured a link, an outbound link to youtube.com. And so if, say, a bunch of different things are linking to youtube.com, we're going to find, you know, that YouTube is going to be bigger in this graph because more people are linking to it, if that makes sense. So that's often why we see Instagram, Twitter, Facebook are always big nodes, because almost every page somewhere on it has a link to, you know, in the footer, in the header, in the content, has a link out to a Twitter, an Instagram, or a Facebook widget, or even just a link, whereas other pages don't.
That makes sense. Thank you.
Yeah, Gephi's usually quicker than this. I'm convinced that Zoom is putting some sort of load on my, probably because I'm recording it, putting some sort of load on my laptop. Yeah, any other questions? I'll put this up on YouTube, and I'll also drop a, we should have a step-by-step walkthrough that basically walks through exactly what I just did. But I know when I'm learning, I often like to see someone do it, and then the reference guide actually makes a little bit of sense.
Ian, when you mentioned like running other algorithms like PageRank, or all of that is like native within Gephi, those are things you can do within the Gephi environment itself.
Yeah, so it's all in this, and Gephi's user interface takes a bit of getting used to. But over on this right-hand side, there's filters, and that's just a way of, some networks you don't need to filter. The Stonewall thing we needed to because it's a pretty big network. And then statistics, there's all these different things you could run. And we actually do on our, website also explain a little bit of what these are, like eigenvector centrality, et cetera. PageRank I tend to use because PageRank, there's lots of, I like PageRank as an algorithm. The idea there is that PageRank weights nodes that have links from other highly weighted nodes more, which sounds complicated, but it's basically like, if you just go straight forward, make it bigger the more links it gets. If you have a link farm in the web archive, which is a big problem in the 90s, you know, some low quality site that's just spamming links outwards to game the system, those will get up, whereas PageRank will figure out, hey, that site is linking to a ton of people, but nobody links to it, so it's probably a low quality link. Whereas like if New York Times is linking out to you, that's more significant than if Bob's Basement links out to you, if that makes sense. And then modularity is neat just because it's a pretty quick community detection algorithm, and it does a pretty good job of clustering websites. So like, you know, it should ideally find your news websites, your educational websites, stuff like that, just based on the sort of link behavior. Any other questions? And then we'll share some links with everybody. Awesome. Well, good luck. I'll put this up on YouTube ASAP, and then I will drop in the main Datathon channel those guides I was talking about. And just ping me if you run into trouble, because I really like Gephi. All right.
Thank you.
All right. We'll see y'all shortly.
Thanks, Ian.